Welcome to another anatomy video. I hope you're having a stress-free day, and today we'll be discussing the bones of the vertebral column. The vertebral column consists of 5 different groups of vertebrae. The first group is located at the most superior end of the column, and these are called cervical vertebrae. And there are 7 of them. So starting with the first vertebra, all the way down to the 7th. These are C1 through C7. Each vertebra is numbered, and it's also assigned to a letter. This letter, the C in front of the number, indicates that it is a cervical vertebra. So again, this is how we number the vertebrae. The second group of vertebrae belong to the thoracic vertebrae. And there are 12 of these vertebrae. Ranging again from T1, T meaning it's a thoracic vertebra, all the way down to T12. The third group of vertebrae belong to the lumbar vertebra. There are 5 of these, ranging from L1 to L5. The fourth group belong to the sacral vertebra. The sacral vertebrae are unique because once the bones begin to mature, they actually fuse together and form its own bone, being the sacral bone. However, when counting vertebrae, the vertebral column includes the vertebrae that were ossified into the sacral bone. So there are, in fact, 5 different sacral vertebrae. So there's S1 through S5. The same type of occurrence happens to the coccyx, which is this bone down here. It has 4 vertebrae. And this group of vertebrae are called coccygeal vertebrae. Now, having counted all the vertebrae in each group of vertebra, we have this formula: C7, T12, L5, S5, and CY4. This formula is called the human vertebral formula. And that is something important and that you need to remember. Now that we've numbered all the different vertebrae and assigned them to their correct groups, we can go ahead and learn the landmarks found on a vertebra. The first set of landmarks that I'm going to show you are found on almost all the vertebrae. The 2 exceptions that do not follow this rule are the atlas and the axis, and I'll go over those landmarks found on those bones later in the video. But for now, I'm going to mention landmarks that are found on all the vertebrae except for those 2 bones. The first landmark that I want to show you is this structure right here. All of this is considered as the vertebral body. The next landmark I want to cover is this projection right here. This is the spinous process of a vertebra. Following the spinous process, we have these 2 projections coming out laterally, and these are called transverse processes. Of a vertebra. And again, those are these projections coming out laterally. We have another set of projections that are going up superiorly, found on each side of the vertebra, and these are called superior articular processes of a vertebra. Similarly, we have inferior articular processes of a vertebra. Now if we go ahead and change views, we can see a few more landmarks shown. Right here we have this space. This hole right here is called the vertebral foramen. The bony structure that surrounds the vertebral foramen right here, this is called the vertebral arch. The vertebral arch can be broken down into two different anatomical landmarks. The first one being right here. The sides of the vertebral arch, located right here, are called pedicle of a vertebral arch. You have to parent it back to vertebral arch. Now, what is considered the roof of the vertebral arch, indicated in green, is called lamina of a vertebral arch. And those two landmarks make up the vertebral arch. Let's go ahead and look at a different view to look at other landmarks. We have a lateral view, and in this image we have two lumbar vertebrae, one on top of the other. In this image we can see certain landmarks that we couldn't see before. The first one being this right here. This notch is called the superior vertebral notch. And this one down here makes the inferior vertebral notch. Now, with the superior vertebral arch of one vertebra and the inferior vertebral notch of another vertebra, they make this kind of a circle right here. This space that's made up by a superior vertebral notch and an inferior vertebral notch is called the intervertebral foramina. And those are found all the way up and down the vertebral column. For example, there would be one right here. If we had another vertebra stacked on top of this one, there would be another one down here. Again, being formed by the superior vertebral notch and the inferior vertebral notch of different vertebrae. Now in this last image I want to show you, I just want to go over all the landmarks that we just learned and quickly review. First thing we have is the vertebral body. We have a transverse process of a vertebra. This is a superior articular process. Right here we have an inferior articular process. This posterior projection is the spinous process of a vertebra. This space right here is the vertebral foramen. And it's made up by the vertebral arch surrounding it. The vertebral arch is made up by two different landmarks. First with the sides being called the pedicles of a vertebral arch. And the roof of the vertebral arch being called the lamina of the vertebral arch. Right here we have a notch, And this is going to be the inferior notch of a vertebra. And this one's going to have a superior notch of a vertebra. Together, both the inferior notch of one vertebra and the superior notch of another vertebra, they make up a space that goes through called the intervertebral foramen. Or foramina if we're talking about the spaces on both sides. The last and final landmark found within a normal vertebra is called the vertebral canal. The vertebral canal is the continuation of one vertebral foramen and going through the vertebral foramen of a second or third vertebra. So just imagine me putting down a stick or a pole or a probe or whatever through both of these vertebral foramens of this vertebra and this one right here, and that's going to be called the vertebral canal. And that's it. Those are all the landmarks found on a typical vertebra. But there's other vertebrae that have more landmarks and others that have fewer. So let's go ahead and begin with the cervical vertebra. The cervical vertebrae are the first 7 vertebrae found on the vertebral column. The first one being called C1. Another acceptable name for C1, and a name I feel is more common than saying C1, is Atlas. Why is it called Atlas? Well, there's a legend in Greek mythology of an individual, I believe he's a Titan, and his name is Atlas, and he carries the world on his shoulders. And I'm sure you've seen images of a man kneeling on one knee while he's holding the rest of the world on his back. They thought that this would be a clever name because the Atlas appears to be holding up the entirety of the head, because it is the first vertebra found underneath the head. So that's why it's called Atlas. Another name that is unique is the second vertebra. The second vertebra is called C2, or it's called the axis, and I'll explain why it's called the axis later. And the final vertebra that has a unique name found in the cervical vertebra is C7. Occasionally, C7 is called the prominent vertebra because it's the vertebra that you can palpate behind your neck, and it's the one that sticks out the most. So occasionally they'll call this the prominent vertebra. Now that I've covered the unique names of certain vertebrae, I'm going to go ahead and dive into the atlas. In this image, we can see not only the atlas, but the axis just underneath it. The atlas is found on top, and the axis is found on bottom. A unique characteristic that is found throughout all 7 cervical vertebrae are these holes right here. These holes are located on the transverse processes of the vertebrae. So these holes are called transverse foramen of a cervical vertebra. Now they have to be parented back to cervical vertebra because they are unique to only cervical vertebrae. So you can't say transverse foramen of a vertebra because not all vertebrae have it. So again, this is transverse foramen of a cervical vertebra. Now the atlas has landmarks that are only found on itself, not on any other vertebra. So let's go ahead and look at the atlas by itself. So in this image, we have a posterior view of the bone. So the first thing I want to cover is this landmark right here. This is called the posterior arch of the atlas. Which means that this arch right here is the anterior arch of the atlas, where the anterior arch of the atlas and the posterior arch of the atlas unite right here. This is going to be called the lateral mass of the atlas. And those are all the landmarks that we need to know for the atlas. Now moving on to the axis, we find the same characteristics that are found on all other cervical vertebrae, such as the transverse foramen of a cervical vertebra, but we also have this projection pointing up superiorly, and there's no other vertebra that has a projection pointing up superiorly like this one. This projection is called the dens of the axis. This dens of the axis helps the head move on an axis. It allows the head not to slip out of place. If we go back to this image, you can see the dens of the axis right here. And the axis, when it pivots left or right, the axis acts as a pivot point. And that's why it's called the axis. The dens of the axis allows the atlas to shift left and right, which is pretty awesome if you think about it. Now going back to the axis, I just want to say that this is the only unique characteristic that the axis has. Again, it has transverse foramen like all the other cervical vertebrae, but it doesn't have lateral masses and it doesn't have a posterior or anterior arch like the atlas does. It just has a normal vertebral arch like the rest of the vertebrae do. Okay? Now let's go ahead and move on to thoracic vertebrae. The thoracic vertebrae have the standard anatomical landmarks that all the other vertebrae do as well, but they have additional landmarks on top of the ones that all the other vertebrae do. The first thing I want you to notice is this little surface. This little surface is called the superior costal fovea of a thoracic vertebra. Now, what is the superior costal fovea of a thoracic vertebra? If you look at these ribs right here, for example, this one, it courses down, and this portion of the rib articulates with the thoracic vertebra. That location where it articulates, that is the superior costal fovea of a thoracic vertebra. There is also an inferior costal fovea of a thoracic vertebra, where I already kind of shaded in. So right there would be the inferior costal fovea of a thoracic vertebra. And these two surfaces are found on both sides of the thoracic vertebra, for the ribs on both sides of the thoracic cage. On top of the superior costal fovea and the inferior costal fovea, there's one other site of articulation between the ribs and the thoracic vertebrae, which is found right here. On the transverse process, there is a surface that articulates with the rib. Since it's found on the transverse process, we're going to call it the costal fovea of the transverse process of a thoracic vertebra. I hope this makes sense. Costal fovea, all that means is rib surface. Costal referring to rib, fovea meaning surface. So this is the surface that articulates with the rib. One being on the superior part of the body of the vertebra, and one being on the inferior portion of the body of the vertebra. And then the third one being on the transverse process. So because of that, we call them the superior costal fovea of thoracic vertebra, the inferior costal fovea of a thoracic vertebra, and the last group being the costal fovea of the transverse process of a thoracic vertebra. And these are the only unique landmarks found on the thoracic vertebra that we need to learn, which isn't too bad. Again, they are unique only to thoracic vertebrae and to none else. They're not found on lumbar vertebrae, and they're not found on cervical vertebrae or part of any other group. Now, this may have been a little bit confusing and a lot to comprehend, so in this image, I've eliminated a lot of the ribs that were articulating with the thoracic vertebrae. Right here, you can see those surfaces that I was talking about found on each thoracic vertebrae. Again, this was the superior costal fovea of a thoracic vertebra. This was the inferior costal fovea of a thoracic vertebra. And then this surface right here was costal fovea of transverse process of a thoracic vertebra. And that actually concludes all of the unique landmarks found on all the different types of vertebrae. The lumbar vertebrae don't have any unique characteristics that we need to learn, so that means we can go ahead and move on to the bony sacrum. Now, the bony sacrum, or you can call it the sacral bone, is a combination of 5 vertebrae fused together. The very top portion of the sacral bone is called the base of the sacral bone. And the very pointed end, down here, is called the apex of the sacral bone. These landmarks may look familiar because they're the same landmarks found on the patella. The base was the more broader end, and the apex was the more pointed end. The same applies here. Returning back to the base of the sacral bone, there is a projection coming out anteriorly, and it's only found in this small portion of the base of the sacral bone. This portion right here is called the promontory of the sacral bone. Just lateral and slightly superior, you have these nice flat anatomical landmarks, and these right here are called the wings of the sacral bone. Now, before I go into any more specific landmarks, there are a few surfaces that I need to cover on the sacral bone. On the anterior surface of the sacral bone, this surface is called the pelvic surface of the sacral bone, and it's this area in its entirety. On the posterior aspect of the sacral bone, this entire surface is called the dorsal surface of the sacral bone. And then the last surface, so there are 3 total, is this surface right here. It looks like an ear, so we're going to call that the auricular surface. Now you may be thinking the auricular surface of the sacral bone, that sounds awfully familiar to another landmark that we already learned, and you'd be correct. There's an auricular surface found on the ilium. And both auricular surfaces, both of the sacral bone and of the ilium, articulate right here. So you can remember ear to ear. Auricular surface of the sacral bone articulates with the auricular surface of the ilium. Awesome. Now we can go ahead and return back to where we were. Looking again at the pelvic surface of the sacral bone, we have these holes. And as we've learned, holes are called foramen. So these right here are called anterior foramina, or foramen for singular, of sacral bone. And those are all the landmarks found on the anterior surface of the sacral bone, but going back to the posterior aspect, we see additional foramina right here. Now you might be thinking, those are the same holes that we saw on the anterior surface. Well, it may appear that way, and even on models it may look that way, but if you look at a real bony sacrum, you'll notice that the holes are actually different. They're aligned differently. So these are actually called posterior foramina of the sacral bone. The next landmark is this hole that goes down here and out this end right here. This channel is called the canal of the sacral bone. And the very last landmark that we need to learn on the bony sacrum is this right here. Right here we kind of have all these spinous processes fused together. This fusion of the spinous processes on the dorsal surface of the bony sacrum, this is called the median crest of the bony sacrum. Awesome. And those conclude all of the landmarks that we need to know on the bony sacrum or the sacral bone, whichever one that you want to say is fine. And now we can go ahead and move on to the very last bone on the vertebral column, which is the coccyx. The coccyx, like the patella, doesn't have too many anatomical landmarks, so all that we need to know is that the coccyx is made by the fusion of 4 vertebrae, and that these right here are called coccygeal horns. And that's it. That concludes all the landmarks that we need to learn for the vertebral column. This video was packed full of anatomical landmarks that we need to know, so it might be wise to rewatch this video and also to study your lab textbook. I hope this was helpful and that you guys succeed in all you do. Take care.